Look who's back on the bench. But this time there's nothing really broken about it, at least not entirely that I can tell. What happened was I had left it running. I went out to run an errand real quick. I came back and I found it in a part of the house and it was just sitting there beeping, complaining about its right wheel being stuck. And so I, thought, okay, maybe something got jammed in there. But there wasn't like a whole lot of stuff on the floor, so it was, it seemed kind of weird. But this wheel was it this one or this one? The right wheel would be this wheel. Okay, so we're looking at it that way, right wheel. It was really hard to turn, so I thought, okay, maybe like hair or something has gotten stuck in the wheel. So I removed it, but there was nothing there. But the wheel was still really hard to turn. So that kind of pointed to there being something up with the motor, like almost like if it was like shorted or something. So I put it back in and everything, but I didn't really find anything wrong. Put it back in. I told it to go again, and it just kept saying that right wheel is stuck, right wheel is stuck. So I'm guessing what must have happened was that the motor was partially shorted, and so maybe the software, was detecting that there was like a overcurrent condition on this side, and so it would just kind of trigger that wheel is stuck. Because if the wheel is stuck, first of all, they can't trigger the little magnetic wheel that's on it to tell it that it's rotating, but also if it's detecting that there's too much current being pulled from this motor, it's going to trigger that this wheel is stuck. So it just kept complaining and complaining. So I had to put it up for a bit, and I couldn't use it for a few days while I tried to get a replacement motor, which I did. I went on eBay and I got a used one, and it's this one right here. And oh man, wait till you see this thing. This is a whole load of craziness in itself, but I won't spoil the surprise just yet. So yeah, so I was gonna put this in, and I did so just because I wanted to see what happened, and I'll show you what happened. But anyways, um, let me just say that by its as is, this ended up not really working. Even though it was, we could have corrected the issue, but I didn't want to because I wanted to show you what what it was. So I'm gonna set this aside right now. So then I measured the resistance of the motor, at the two terminals on the motor, and it seemed a little funky on this one. This one, I measured it as well, and it was kind of measuring about like 10 to 12 ohms or so, like just normally, even like, like rotating the motor a little bit, measuring again. This one here was like kind of like down in the eights and sevens. Sometimes like it would hit six, and sometimes it would spike up to like 10 ohms. So this one, yeah, something really weird going on. And yeah, they're both, I mean, they're all 12 volt motors. So another thing I wanted to do is I also wanted to check the current draw on this motor. I will check this motor. We'll do this motor as well. But then I also ended up getting another wheel. This is actually a left one, but I got the left one because if anybody saw like one of the earlier videos I did on this, that the whole bracket thing was broken. So I just kind of got a left one, just as kind of like a backup. But this one seems fine. The motor looks totally okay, although the board design is slightly different on this one. But I mean, that's not a big deal. So anyways, let's remove the motors here. We'll run a current test and see what kind of current we should be expecting to be pulling on one of these motors. And then we'll get to this in a bit. Oh yeah, and one last thing before we do that. I actually put the original motor back in after kind of having it out for a while, and it went back to working as normal. So I'm wondering if maybe there was just like a lot of carbon buildup in the commutator or something, and it was just causing it to look like a short to the rest of the circuitry, the software and all that stuff. But it's been working fine with the original motor. Like I said, it just had kind of like some weird readings, but it's been working fine after that. So I've been using it, and I haven't even bothered to put this other one in or anything. All right, so yeah, let's get to it. So here's all three of the completed assemblies, and you can see that these two right here are my original ones, and these have like a little fuse built in right here and right here. And here's the little magnetic wheel. This is the one that I got just recently, so there's a magnetic wheel. But this one has no built-in fuse, and you can see that the board here is actually a lot smaller. So it's like they eliminated that fuse on a. This must be like a newer design, I'm guessing. And so this just goes straight to the motor terminals. And we can also see that on this one here that they actually have some, like they put some adhesive or something there to kind of hold those wires down. On mine, they don't really have that. So I'm guessing that, you know, they did that just to kind of prevent like vibrations from breaking or something. Although it hadn't really been an issue on mine. But also on mine here, like they've drilled some holes in the board and how the wires kind of going out through those. So I guess, you know, that kind of supports it that way. This one here, they just have this like big cutout, so there's a little bit more like wiggle room for those wires. So, you know, they could like break a lot easier that way. But so I guess that's what they use the adhesive for. Nothing too much else is different. My wheels look a little bit more clear than this one here. Looks a little bit more yellowish. I hope that doesn't mean anything. But okay, so what we're gonna do here is I'm gonna get my multimeter. We're gonna set it to measure amperage, and we're gonna check one at a time and just see what kind of, you know, current each one pulls. Just, you know, with the whole gearbox and everything. I'm gonna set a power supply to pretty much exactly 12 volts, and then we'll measure each one and we'll see what we get. Before we do that though, let's measure the ohms on these motors. So let's check the left wheel first, because the left wheel was the one that was completely fine on mine. So if we just leave the motor where it's at and measure across its two terminals here. Oh, well, okay, so it's measuring down about 6.7 or so, 6.6. Let me rotate it a little bit here. 7. Okay, so maybe I was thinking of something else. I don't know. It was a while ago that a few days ago that I did this. So, okay, so 8, 7. Okay, so it kind of seems to be like about that range. Okay, we'll set that aside. Let's check the one that I messed with, the one that was supposedly acting up. That's measuring 6, 6.6, 6.5. Huh, that's weird. Now I'm getting like some slightly different readings, but it seems to be pretty consistent with the other one. So it seems, I mean, I would guess that's why it's working fine. And like I said, it's, you know, it's not hard to rotate anymore or anything. So that's why I'm guessing maybe it had a lot of like carbon buildup on the comm. But okay, well, it seems fine now. And I don't know why I was getting 12 ohms or 10, 12 on that other one before. So let's check this other one that I just recently bought. And holy crap, this one's way higher. So 12, 7, 8. Well, that makes no sense. 8, 7. What the heck? 16. I don't get it. I'm just going to rotate it really slow. Yeah, I don't know. Well, okay. Well, they all seem pretty much the same. I don't know why I was getting 12 on this one. Here, let me rotate it a bit. And let's see. Let's check it again. 6.8, 7. I mean, it varies a bit when I like even just shaking it, like the, you know, the magnetic field like changing on that armature kind of changes the resistance a little bit. But other than that, it seems pretty consistent. So all three of these are pretty much measuring about the same. So let's check the current draw and see if, you know, we're expecting the same thing across all of them now. I'm not really measuring anything weird now, so I don't know. But let's try it anyway. Okay, I have the power supply like with the knob just turned all the way down to 11.7, because if I try to do 12, it seems to drift a little bit, and I don't want that affecting the readings too much. So we're gonna set this now to measure amperage, and I'm gonna put my, well, I gotta unclip these first. Okay, so let's put this on the amperage. So okay, now we got our positive and our negative, and let's check my original left one first and see what kind of amperage reading we get from that. Alright, so it's about just slightly over 100 milliamps at that 11.7 volts. Okay, so now let's check my right one. See what that reads. Yeah, that one actually, it's a little bit lower. So, that's interesting. Okay, so it hit about 100 there for a bit. So, okay, they're both about pretty much about the same though. Now let's check the one I got. And yeah, about 100 as well. So, no difference in any of these three. So yeah, I wouldn't expect to have any issues at all. This one here though, I guess the gears sound a bit dry. Where the ones on mine, they sound a bit smoother. So, I don't know, I guess maybe I have a little bit more lubrication on mine then. Yeah, this one sounds a little... Yeah, it sounds like these gears are a little bit more dry than mine are. So, anyways, well, I was really hoping we'd get some, like, you know, different readings on these things, but really not. So, I guess whatever the issue was with my right one is completely gone now. And that's kind of disappointing. I was hoping this would be a little bit more exciting. There'd be a little bit more to show, but I guess not. But anyways, so let's move these aside. Let's get to this one. Alright, so on first glance, one thing you might notice is that it looks kind of... yeah, it's seen better days for sure. But, I mean, you can turn it. So that's not a big deal, although this little pinion gear here does look a little bit like it's got some wear on it. And yeah, it's got like a little bit of tarnishing, maybe like some slight kind of surface rust there. But check it out. This is my original right one. See? Okay, so it's not, I mean, this one, it looks pretty good, you know, considering everything. And, you know, rotates everything. Let's look at the boards underneath. Okay, got my little fuse right here. Check out what they did here. It's just a wire, but this isn't factory. I guess whoever had this replaced it, that fusible link there, or little fuse, with just a piece of wire. So, okay, that's one thing. We can see that the boards here are pretty much the same. It's like the same design. It's just the material's a little different. Like this one's like this fiberglass, like FR4 type stuff. This one's some other stuff, not exactly sure. But anyways, so let me turn it this way. Notice anything different? You see up here? You see that? Well, these motors, you know, they do have a positive and negative side. And we can tell that these have been worked over before. So whoever had this at one point removed this board. For what reason? Well, you see that there? You see that there? That's where the motor is crimped down to, you know, hold the back in place so that the back end little sleeve bearing there doesn't pop off, and where the, you know, the commutator and everything is, the brushes. So they've opened up this motor before. So this motor had some issues. Probably I was experiencing something similar, you know, with what was going on here. And like I said, I put this in and it does work, but because of the fact that the positive and negative are switched, as you can see there, I mean, this is how it's supposed to be. And on the motor, this side here is marked positive. So because these are switched, the vacuum, instead of, you know, moving like properly, like say it's supposed to go forward, you know, it would go forward, or if it's supposed to turn, you know, like the motors turn in different directions. When the when the vacuum is supposed to rotate, it just keeps going straight. Like it just goes straight until it hits something. It will not like react to anything. So I thought that was super funny. And the funny part is that when I put this in, I didn't realize that the motor was backwards until I saw the vacuum was just like acting like super weird. It was just, you know, like it was not doing what it would normally do, like at all. And that's when I tore it back out, and I was like, oh, okay, that's what happened. Somebody, when they took this apart to try to fix it, they just soldered the motor in backwards. So yeah, so like I said, this motor works, but it looks like crap, and there's no fuse here. These solder joints, yeah, they don't look so hot, and this motor's been opened before. So, but I mean, I got this like so dirt cheap. I wasn't even going to complain about it. I thought it would be like some good material to show here. So, I mean, this motor, you know, could be fixed up a little bit, and, you know, we could get it going again. And like I said, it would work as like a replacement if I really, really needed it. For the time being, I'm probably just gonna keep it somewhere. It's not like it's completely dead or anything, but I just thought that was hilarious. What happened to this thing? I realized during editing that I forgot to check the current draw on this other motor here, so we're gonna test it here real quick. We're just gonna hook it up and see what we're getting. Same voltage and everything, and it says about about 120 there. So yeah, it's not too horrible. It's about pretty much on par with all the other ones too. And that's with nothing having been done to this at all, because I haven't really like lubricated it or tried to blow it out or anything. This is just how I got it basically. Under normal operations, this here is what we would expect. So it's on right now. I'm just going to start it. And of course it's going to ramp up. So right there it's just kind of scanning like it should normally do. And then it takes off like normal, and then it'll go on and do its thing. And now I'm going to start it from the exact same location, but with the reverse motor. So we would expect it to do something similar, but watch. Instead of turning it, just go straight, because it's trying to rotate, but it can't. Right there it would still be trying to rotate, but it can't. I decided to try one last little experiment here just to see if it made any difference. This is my right wheel motor and this is my left wheel motor. I took the right wheel motor and I tried to blow out the comm there with air compressor, or yeah, compressed air, to see if it made any difference. And check it out now. So we're going to put the negative down here where the negative terminal of the motor actually is, and then we're going to touch the positive. And okay, I need to make sure that the wire is not rubbing on the magnet there. I'm getting like, and the other reason I have these out of the gearbox is so that the gearbox doesn't introduce any drag onto the motor. To drag or friction is going to increase the current draw on these motors. So right here, it's just the motor by itself, and this is what we're getting now. So after I blew out the comms there, I'm getting down to like, geez, now it was like hitting like just high 70s, but it's 80s, 70s there. So yeah, it's a lot less than it was when we had it in the gearbox for sure. But it's not just the gearbox that's making a difference. Check it out. This is my right wheel motor, and I haven't touched this one. I've just left it as is. So got the negative there, positive. I'm hooking it up, same orientation and everything. And now when I touch this one, it's consistently over 100 milliamps. So it looks like carbon buildup on the comm there definitely makes a bit of difference. So what I'm going to do now is I'm going to take this left wheel motor and I'll do the same. I'll blow out the comms there and see if it makes a difference on that reading. Alright, I blew this one out, and now let's see what we get. See if it made much of a difference at all. And the only way we can denote that these are, is because this one's a lot cleaner, because this is the one I've been messing with. This one here still got a little bit of dust and stuff on the magnet there. So let me hook it up here again, same way. And now let's see what we get. Oops, I got the terminal there rubbing on the magnet. Okay, the alligator clip was rubbing on the magnet there, so that was introducing a lot of friction. So now let's see. This one is still reading quite a bit higher than the other motor, so yeah, that's really odd. Let's check this one again. Oops, rubbing. Ah. Okay. Ah. These terminals are so close to the magnet that it's hard to clip this on without it rubbing or anything. Here we go. Okay. Huh. Yeah. Okay. I put a droplet of this 3-in-1 stuff on the ends of like the little bushing inside of each one of these motors. I actually removed the magnets and then I put a little droplet right there. Spun around a bit, try to get that oil to, you know, kind of go in there into the bushing and see what kind of difference it makes. So once again, this is the right side motor, the one that I was originally having issues with. And we're going to check now. And seems to vary quite a bit there, but it's mostly staying like high 80s, 90s. I don't know why I'm getting such a high variation. Wiggling around doesn't do much, but anyways, it's down like high 80s, 90s now from what we're reading. Okay, so now let's check the left one again, and this is after adding the oil. So now it's down in the low hundreds there. So it definitely made an improvement on this motor. I'm guessing maybe there was a little bit too much friction there between the shaft and the bushing. So yeah, it definitely helped this motor a bit, and it didn't really do much for the right side motor. And I think that's funny considering this was the one that was the problem originally. But I mean, so I'm not expecting to have any issues with these anytime soon now that, you know, everything seems like it's fine. I'm guessing at some point after I took this out and, you know, I was messing around with it, trying to power it up and all that stuff, I'm guessing I must have loosened up whatever was in there that was causing it to short, because it was also like really hard to rotate, but it wasn't that, you know, it was friction on the bushing there. Like it felt like it was something to do with, like, you know, magnetic forces, because, you know, when you short it, like when you short a motor, it gets noticeably hard to turn, and you can kind of tell because, you know, like say if you like try to rotate it slowly, you're able to do so, like, you know, fairly easily, but when you try to go faster, you know, then you feel that resistance, and that's sort of what this one was doing. That's what leads me to believe that, you know, it's just probably carbon buildup or something there. So this motor totally fine. I thought it was going to end up having like a shorted like winding on the armature there, but yeah, apparently not. It seems to be completely fine now. So I was really hoping that, like I said, you know, that this would be a lot more exciting, that we'd be able to find out a lot more. But yeah, I guess it really wasn't that big of a deal, and I ended up getting 2 other motors for nothing. But at least they were like super cheap, so I really didn't spend a lot on these other ones. Like I said, I think this one was like less than $4. So, and it kind of gave me a little bit of comedic value there. So yeah, that was, yeah, totally crazy. But oh well. So yeah, I thought, you know, we could be able to do more, but I guess not. So all right, well, if you've watched this to the end, I guess thanks for watching once again. And, you know, if you like this kind of stuff, remember to subscribe, and I'll see you guys around the bench.